Okay, good morning. Welcome to
FamilyMath number 714.
Family Math 714. So today we're going to talk about a neat thing that was in a paper that Steven Strogatz wrote, and this is somebody on Twitter named Nikki Case tweeted out this link to something called the Swarmulator. Okay, and so what Steven Strogatz studies, his field, or I shouldn't say what he studies, one of the things he studies is how things sync together. Like, have you ever seen fireflies?
Yeah.
And how they tend to blink around the same time if they're near each other?
Yeah.
Whereas, a firefly that was 100 miles away probably wouldn't be blinking at the same time.
Yeah.
And so how he likes to study how things tend to sync up. And then also, this time around, they were studying how things tend to swarm and sync. So they have two variables here. One's J and one's K.
And is N is the number of dots.
N is the number of dots, yeah. So J represents the attraction between phases. So if two fireflies are blinking at the same time, they attract each other. J greater than 0 likes attract. J less than 0 opposite phases attract. Okay, so if we make J bigger than 0, which we've done here, we...
Opposites attract.
Nope, likes
likes
attract. And you can see in the picture that we have blues seem to be with blues, oranges with oranges, greens with greens.
Yeah.
And K is the strength of the phase coupling. Neighbors want to have the same color for K greater than 0. Okay?
Difference possible for...
So if I make K greater than 0 here, you'll see the picture changes. And what happens?
Everybody is the same color.
Everyone's the same.
If I go back and I make it negative and neighbors want to have different colors, then we get...
Jumble.
Yeah, let's call it a jumble. I'll go back to 0 here. So that gives you kind of a peek of what they're studying. So there's two variables. One variable likes attract or don't attract. That was J, right?
Yeah.
So here likes attract. The second variable is phases. Either the neighbors either want to be the same or be different. Here we're kind of in the middle, so neighbors really don't care what their neighbor is. Okay. So before we start investigating this, what are some things that you think will happen as we tune the dials here?
Well, I think when K is negative and J is positive, we'll get that jumble sort. I'm gonna get like a sort of jumble when they're all moving.
Oh, interesting. Okay, so if I make J positive, which means likes attract, and K negative, meaning close people want to have different phases,
Yeah.
then you're going to get a jumble. Okay, that's an interesting observation.
And then what's DT here?
Oh, DT is just the
Difference
time step. So T is time, D stands for difference. So here you're making small steps. Well, actually, no, sorry, this is at the largest step. So if I show you this one right from the beginning. Okay, and now I'll change DT to be smaller. 0.2 instead of 0.5. So 2.5 steps for every one step before. Let's watch what happens.
So it just sort of goes slower.
Yeah, well, let's see if it ends up in the same place, because now this is a more, you would think this would be a more accurate model of what's happening. And actually, you see, we didn't actually end up at the same place. So when you're modeling things, actually this time step that you look like, so 0.02 later versus 0.05 later, actually can't have an effect on the outcome. But we can study the outcome with this effect removed by just keeping it constant.
Okay.
So what is something you expect to see by playing around with the J, which attracts, likes want to be together, and K, neighbors want to be either
Well,
the same or different?
We might have, if we have K negative and J positive, we might get sort of like a clump that's just all the same.
K negative would mean they would want to be different. Their neighbors would want to be different. So what would you need to get the clump?
So that both of them positive would give you a clump.
Both of them positive would give you a clump. Okay. I'm going to let each one of you play around with it just for a few minutes on
Okay.
camera, and then just tune the dials and see what you get.
All right.
Okay. Who wants to go first?
I will.
Okay.